Welcome to the Evidence and Reasons Academy. This is the sister channel to the Evidence and Reasons video channel. And this channel is formally separate, where we explore more very technical and academic aspects of evidence and reasons, but it can almost stand on its own in that we, here at this channel, we study basic math, physics, chemistry, and biology. And so today I'm privileged to be joined by James, who had contacted me and he saw one of my journal club things, and we might do a little bit of that today, but he also had some ideas he wanted to talk about. So James, tell me, how did you find me? I'm just very curious.
Well, I discovered your channel through the, how should we call it, the online debate sphere. These channels like Modern Day Debates and, you have all these, it's basically, it's sort of a subculture within YouTube, I guess.
Which debate did you watch all my debates, or was there one in particular?
No, I discovered you through the debates with Dr. Dan.
Ah, okay. Yes. Well, now I'm really glad I had that debate. So we can talk about that or sometime. So how can I be of service to you? I'm really glad you also did look at some of my journal club stuff. Now I kind of know your background, and there are people who are not professional biologists that would like to learn some biology, chemistry, math, and physics that's related to this. And my goal is to try to help people to be able to learn very, very quickly the essentials to be able to understand the creation evolution controversy without having to go through 6 years of college. Because in a typical college program, they're more oriented to training people to become chemists, biochemists, medical doctors, dentists, pharmacists, biologists, and not necessarily kind of equipping them to understand the creation evolution controversy. And so there are a lot of things I think we can learn quickly without having to go through a program like that. And that's kind of my hope, because there are a lot of engineers and computer professionals that are interested in this topic, but they don't have 6 years to invest to get retrained to understand it, and they don't really need that. My hope is to help them. So you had some topics you wanted to talk about, and just share what's on your heart. We'll just see where the discussion goes.
Well, there are two topics I would like to discuss. The first one might be a little bit controversial, and I guess you wouldn't agree with it either. It's about the issue of taxonomy. I have my doubts about taxonomy, and I'm not saying it's totally arbitrary, but I personally believe that ultimately, you can categorize everything, but it doesn't mean that the categories reflect any inherent qualities that they maybe the audience doesn't know that English is not my native tongue, so it's not necessarily easy to make myself clear at this point. Let me see, how can I explain it? So I basically think that convergent evolution is very unlikely. For example, you have the, if you look at marsupials, you have like the marsupial wolf, I think it's called in English. I'm not sure, I can look it up now.
I'm going to share a graphic with our viewers here. This is the claim of parallel evolution. So we have like the marsupial squirrels. One of them's...
Yeah, right.
And another is the placental. And then we have that with the mice. there is the wolf over here. This wolf, and there are some others like the wombat, the kind of the cats, the anteaters. So I was just sharing that with the viewers regarding the claims of convergent evolution. So creationists would say these are probably independently created, that they didn't descend from a common ancestor. But if we assume common ancestry, it's still kind of a miracle that they would. Is that what you're saying, that they would look so similar, or are you saying that it's
even back when because I used to be an atheist, and I, of course, probably the atheists in the audience won't believe that, but anyways, and I used to believe in evolution, and of course they will then say these things like, well, then you never truly understood it, or stuff like that. Anyways, I could never, I thought a lot of things made sense, I will be honest with you, to prove to the viewers that I actually did believe in evolution, and I still believe to some extent. For example, I think sexual selection makes a lot of sense, because I think we see it reflected in human psychology. So I think I think a lot of things with regards to sexual selection, for example, can be confirmed by science. But with regards to speciation, the whole notion of convergent evolution never made sense to me, because you have these animals that the idea that ultimately it comes down to the issue of taxonomy, because why the idea that we should classify Tasmanian wolves, marsupial wolves, Tasmanian devils, kangaroos, etc., in one clade, and then wolves and mice, etc., in another clade. I think it's arbitrary, because you could just as well say that marsupial wolves and wolves belong in one clade, and I don't know, the flying squirrel and the flying marsupial belong in a different clade. At least that's how I looked at it. I think from a philosophical perspective, it's ultimately arbitrary.
The way that the way that I look at it, if we're able to ever have just very strong physical evidence that the Earth is young, we have some evidence, but not. People know that I'm a young Earth, young cosmos creationist, but when I say physical evidence, meaning that one could, if one didn't have any philosophical or religious predisposition, we could just take our best science at some point and say, well, if we look at just the pure science, the Earth is young. There's a lot of evidence on both sides at this time. I know 42 years ago, when I was looking into the questions of evidence and reasons for the Christian faith, there were arguments that didn't exist then that exist now. And I fully was committed to the idea that the Earth is old. And my first year as a Christian at age 15, I still accepted evolution, but by about age 17, I'd rejected it, but I still believed in an old universe. But as I studied physics and other things, I began to say, well, it's at least an open question now, because they're anomalies. So where I was headed with that, if there's just not enough time, then it'll make it easier to say that these things were created and not evolved. And that might make it easier to say what clades are really what clades, in terms of what, in terms of what created common ancestors there were, we can have a better estimate. So that's just kind of my view. But the convergence is still very amazing, because when even evolutionary biologists admit, it's kind of amazing that the creatures look so similar. It's like a common design. Why should they evolve to the same design? That's amazing to me.
Yeah. Yeah, I mean, some of them, like the flying squirrel and the the other one. I don't know what its name is, but of course I'm a layman, but they just look extremely similar.
And that's what I call common design. And there are like eyes. They said the eye, optical sensory organs they said they've evolved 40 times independently.
Yeah.
They said that their 20 independent multicellularity evolved 20 times, 6 to 20 times or more independently. And we're getting a lot of these situations where there was so much independent evolution, and why does it arrive at the same, very similar architectures?
Or very weird symbiotic relationships, like you have some plants with certain, like with bees, some plants have very elaborate symbiotic relationships that are necessary for the reproduction of these plants. I mean, how could that have been evolved? I think that's just insane to believe that.
Exactly.
I mean, the idea that it could have evolved per se isn't that idea isn't insane, but the idea that could have evolved through the whole process whereby random mutations create enough genetic variation, and then that natural selection would act upon that, and that process would create these elaborate systems, is just ridiculous.
Yes. So the whole topic in general is, there is a Wikipedia devoted to convergent evolution, and it even happens at the molecular level, that they converge on the same. So even if we assume universal common ancestry, there are all these things that just look it doesn't look like random mutation and natural selection. I think this one's
also
yeah, go on.
What's also interesting is that I recall watching Dr. Dan's rebuttal of genetic entropy, and one of his claims was, well, genetic entropy cannot be true because it is what's the fallacy called? Begging the question? Is that what it's called in English?
I've heard that. Yes.
Yeah.
You go.
So he claims that because he says, well, because John Sanford, he assumes that the human genome started out perfectly, but it works both ways. The sword cuts both ways, because within the if you Dr. Dan, he is assuming that the genome wasn't perfect in the beginning. So we are basically at the level of, well, I decide to believe this or that, and that these are de fide positions that have nothing to do with science, and they are only based basically upon our ultimately will to power, as Friedrich Nietzsche might have said.
Well, one thing I'm going to point out, by the way, this is a convergence here. On the left is like an octopus or cephalopod eye.
Yeah.
On the right is the human eye. And it's like, okay, so these supposedly evolved independently. So the lens evolved independently in all these structures here.
Yeah.
So that, as you said, that's hard to believe. Now, with respect to Dr. Dan, this is an issue that I pointed out, is that we don't have to assume it's perfect. I mean, perfect is not a word that's that's defined in science, but in biophysics, we have the notion of optimality. So even an optometrist or ophthalmologist, when I was getting corrective lenses, they could just take these instruments and then start adjusting the lens and say, okay, now can you see well? And I'd say yes. And they're able to use principles of physics to say, okay, the lens is now tuned to your eye to make it optimal for focusing. And so there is a point when a lens is in someone's eye, their natural lens here, is focused or unfocused. That's not a matter of, being perfect or imperfect in the biblical sense. That's just basic principles of engineering and optics for the eye. And I tried to show this. Let me see. Potassium ion channel. And we can actually define this. Let me see if I have pictures. This is
I know about that.
Oh yeah, excellent. And so I will then just repeat it for the sake of our viewers who may not be familiar with the potassium ion channel.
That has to do with let me see, how do you say it in English? With the in my language we would call it the membrane potential, yes. I guess. Yeah.
Yes, exactly. And
okay.
If this channel, when they say angstroms or subangstroms, this is less than the length of a atom. It has to be, the hole here has to be precise within the length of an atom or less. It's very hard for even human engineers to construct a molecule that has a hole exactly that size. I don't know any biochemist that could do that from scratch unless they had a working model like a potassium ion channel. And so the idea that this could be broken, it's not a philosophical one. You could just say it's not going to be able to perform the activity or function of moving a potassium ion across a membrane. So therefore, there's no way that this can be made to function more perfectly to pass a potassium ion. The only thing that a random mutation can do is at best it'll be neutral, but in general it's just going to degrade the size of this hole, of this tunnel here, and that's again accords with the idea that it's more likely to break than make anything. It's going to also be very hard to evolve this to be any other kind of system because it would have to be broken before it could do another function. So Dr. Dan and I never had that discussion on the idea of what constitutes really being fit or operationally fit. So what I wanted to say then is we don't have to, he was saying that genetic entropy assumes that the creation is perfect. And I was just pointing out, we don't have to make that assumption. It may be in Dr. Sanford's original book, but we can still say the genome's decaying, even if we don't have a definition of perfection, like as in Adam and Eve. We don't need that. And that's why I was trying to point out examples like the potassium ion channel to show that we can demonstrate this in terms of physics. And that's one of my favorite fields right now is biological, or what they call biophysics.
Yeah. Can you hear me?
Yes. So that's all I had to say on that topic for now.
Oh, okay.
And it's something we can revisit You mentioned you wanted to talk about something else, or did you want to continue on this topic of convergence?
Well, I just, it seems to me like, I mean, it's a, hypothetically, it's possible that convergent evolution happens. I will
Yes.
grant that. But is it plausible? I don't think it is. And I think it only becomes plausible if you have the a priori position that evolution is true. And I think if you look at it from you could say that perhaps some phenomena in nature, I'm going to be honest, like I think in Latin it's called de vas deferens, somewhere along the testicles. It sounds a bit nasty, but you have these veins that, I do get the evolutionary argument that it would make that it doesn't make sense that that's designed because, of the way it looks. So I would say that from perhaps a non-judging perspective in that scenario, the evolutionary story makes more sense, or with the what's it called, laryngeal nerve or something with giraffes or something.
Recurrent laryngeal nerve.
Yeah. Okay.
Yeah. Go on.
So I get that, but then on the other hand, I do think that when you look at something like convergent evolution, which is a much bigger topic, it's much more impressive. In that scenario, I think the creationist explanation actually makes more sense. And then you have to make the assessment, okay, ultimately, which paradigm explains most of the data? Because every paradigm has anomalous data. Every paradigm.
And the thing about like the recurrent laryngeal nerve or the backwards wiring of the retina, further investigation, particularly by physicists and physiologists, have shown that that's not really the best assessment. In fact, it's very poor. It shows that we didn't understand the technology well, particularly with the backwards wiring of the retina. We now know that it's highly optimal. It's extremely ingenious. It's something a human engineer would not be able to build.
Yeah.
The reason I know that is I talked to someone who works in electromagnetic theory, and I described the latest developments, and he was just astonished. He said, that has to be so well engineered to be able to do what it's doing. And he was just overwhelmed. So, he looked at it differently. So I said, here's a story that the evolutionists have said this is so poorly designed for decades. And then now the people that actually study biophysics, that's why I like biophysics, they have a more objective way of saying whether this is poorly designed or not. And in so many cases, we're just looking at it the wrong way because it's optimized for certain things. So if something is optimized, say, to fly versus to swim, it is organized under different engineering principles. And it's usually always at the limit of what is physically possible, and usually a few steps above what any human engineer could build. And so a lot of times, the technology in biology they think it's junky until they actually start to understand what it does. And most of the time they don't understand what it does. And they just, the evolutionary biologists will say it's junk. And then we'll learn more and we realize, oh no, it's not. It has this function. And by the way, not only does it have this function, it's able to do.
Could you send some articles on?
Well, you see, now this is what's, I have an idea now that what we can do for our journal club is to explore biophysics discussions. And I was just showing the thing with the potassium ion channel. That's pretty brutally obvious, but there are some other physical principles that are not quite so obvious. You wouldn't realize it unless you were like, say, a physicist and an engineer working in a very specialized discipline like construction of electromagnetic waveguides, most evolutionary biologists would totally not understand electromagnetic waveguides, but an engineer does. And when they apply this to biology, they're usually astonished how well implemented it is. Because again, just like with the potassium ion channel, sometimes the precision has to be atomic level precision. And that is incredibly hard for our best engineers to be able to engineer something with atomic precision in terms of its three-dimensional, like building a tunnel, because there's lots of things that have tunnels in it in biology, and the tunnel has to be exactly the right width. So let me think about that. And the thing that I don't know, did you see my last journal club on combinatorial gene expression?
No, I haven't seen it.
Okay. Why don't I just cover the abstract of that? And then that may give us some ideas. It may be worth repeating because that was actually one of my more favorite articles. So let's see, combinatorial control of gene expression. So I'm going to put this up on the share it on the screen here. And let me see if I can make this bigger. Let me get the PDF because it's going to be nicer if I do that. And now I'll share my screen. So this is just a qualitative. This will be just kind of qualitative, but then I have a book on biophysics, and we could probably play some of the biophysics stuff. I'll have to dig it up, but this is what I thought was interesting, because this doesn't sound anything like an evolutionary biologist would write. And so the topic was combinatorial control of gene expression. It says in the abstract, the complexity and diversity of eukaryotic organisms are a feat of nature's engineering. So they first used the word engineering, not design, but that's kind of the same thing, a feat of nature's engineering. Pulling the strings of such an intricate machinery requires an even more masterful and crafty approach. So this is already saying, these are words that we're talking about. The word crafty relates to intelligence. So they're saying it's masterful. So even in the first two sentences, we're getting hints of the excellence of how this is done. Only the number of type of responses that they generate exceeds the staggering proportions of environmental signals perceived and processed by eukaryotes. Hence, at first glance, the cell's sparse stockpile of controlling factors does not seem remotely adequate to carry out this response. The question as to how eukaryotes sense and respond to environmental cues has no single answer. It is an amalgamation, an interplay between several processes, pathways, and factors, a combinatorial control. A short description of some of the most important elements that operate this entire conglomerate is given in this paper. And so when we actually start to study the mechanisms, it's really jaw-dropping, because we can't build anything that is this capable. And we can kind of cover some of these. So there's some that we can cover that are more general like that. And then there are parts that are in biophysics where they actually put numbers to this and say, yeah, we're never going to exceed this. So maybe to highlight what I'm trying to say, Natalie Angier. So this is from the New York Times. Biophysics. I'll look at it. See, biophysics. Natalie Angier. It was so well written. This is just too bad. I used to be able to just Google this. Maybe Google's suppressing some of the more interesting. Let's see. I apologize here. I'm trying to get. I'm going to go to a blog by Cornelius Hunter, Darwin's God. Maybe I can get the. Apologies to the reader. I thought I would be able to get this easier. I'm going to try one more time because Google's giving me a hard time, which I didn't have before. And yeah, I'm going to go to Cornelius Hunter's blog. Cornelius Hunter. Okay. Yeah, I think Google is kind of not letting us Google certain things as easily as we used to. And that's really sad. So, because there were really some very good Dr. Hunter may have deleted his blog.
Does Google actually suppress creationist content? I know they do suppress certain political things, but
that's a good question. I don't know how their algorithms work. They do that's an interesting question in and of itself. So let me see. I'm going to try. Okay, let's look at this. William Bialek, more perfect than we imagined. All right, so this is from Cornelius Hunter's blog, but it refers to a, again, I'd like to thank the readers for their forbearance. Let's see, I'm going to try to share my screen again. This is from darwinsgod.blogspot. You can, I'll put that in the comment section. And this would be worth watching. We could probably watch this together by Lex lecture. We can do that sometime. Here is what here's how one science writer explained it. Yet, for all these apparent flaws, the basic building blocks of human eyesight to turn out to be practically perfect, scientists have learned that the fundamental units of vision, the photoreceptor cells that carpet the retinal tissue of the eye and respond to light, are not just good or great or fabulous at their job. They are not merely exceptionally impressive by the standards of biology. With whatever slop and wiggle room the animate category implies, photoreceptors operate at the outermost boundary allowed by the laws of physics, which means they are as good as they can be, period. Each one is designed to detect and respond to single photons of light, the smallest possible packages in which light comes wrapped. Light is quantized, and you can't count half a photon, said William Bialek, a professor of physics in integrative genomics at Princeton University. This is as far as it goes. Photoreceptors exemplify the principle of optimization, an idea gaining ever wider traction among researchers, that certain key features of the natural world have been honed by evolution. That's not true, but we'll let it go. Have been honed by evolution to the highest possible peaks of performance, the legal limits of what Newton, Maxwell, Pauli, Planck, and Albert, that's Albert Einstein, will allow. Scientists have identified and mathematically anatomized an array of cases where optimization has left its fastidious mark. Among them, the superb efficiency with which bacterial cells will close in on a food source, the precision response in a fruit fly embryo to contouring molecules that help distinguish tail from head, and the way a shark can find its prey by measuring microfluxes of electricity in the water, a tremulous millionth of a volt strong. Actually, it's volts per nanometer, but I'll let that go. Which, as Douglas Field observed in Scientific American, is like detecting an electrical field generated by a standard AA battery with one pole dipped in the Long Island Sound and the other pole in the waters of Jacksonville, Florida. That's about 1,000 miles. In each instance, biophysicists have calculated the system couldn't get faster, more sensitive, or more efficient without first relocating to an alternate universe with alternate physical constants. So that was the popular article I wanted to talk about. So the idea of what is perfect doesn't have to assume kind of the theological views of Genesis. We can define it in terms of biophysics. And that's why I was advocating this is how we can define like what I call kind of operational fitness. We can say that the system is optimized for this, therefore random mutation will definitely degrade it. It's very hard to run away from that at this point. So I can think about articles and things we could do to study this. So being a student of engineering and physics, my jaw dropped. I said these were classes I was studying because engineers always work on trying to make their products better, but there are limits of physics of how much we can make a product do a certain thing given the materials we're working with. And the way it's done in biology is better than anything we can even dream to do. It's done just so well at so many levels, even from the way a fish is able to swim through water, something we just kind of take for granted. We can't make our submarines operate with that efficiency. I talked to someone who was Dr. Sanford's associate. His name is Wesley Brewer. He was a MIT PhD in fluid mechanics. He said the way the fish does things, we wish we could build ships that are so efficient through the water. And it's just on so many levels. It's perfect. So maybe we could watch that video by William Bialek. I can dig it up and we can watch it together. It'd be worth it to hear it just straight from him sometime.
Yeah, that's okay by me.
Yeah. So you had maybe we I think I have a better idea of where we'll go, and then we can also. You wanted to join kind of the journal club, and so we may go through some papers kind of tediously, where we run the risk that we don't really get any data point that's going to help us in our understanding of creation evolution. That's the risk we take when we start to just go in the library and just look, and there might not be anything there. But that's actually where some of the biggest gains are, is we'll just look at something and say, yeah, maybe this might help. And then sometimes we misfire, but then sometimes we hit a gold mine. Or there are times just in my own reading, I think I find something and it's like, okay, let's just go through this paper. It may be mostly boring, but it has a lot of what we might be looking for.
Yeah.
Okay. Was there there was something you wanted to share about life expectancy? Do you want to talk about that today before we call it a day, and then we can meet again sometime? James, if are you there, James? Okay, so
Okay, wait. I'm back.
oh, okay. Did you want to
Yeah.
talk about life expectancy?
Yeah, that's okay.
Okay, so I'm gonna post some things in the side chat. The
Do
so
you
there
have
was a,
any upcoming debates, by the way, or do you not?
I don't have any upcoming debates. Oh wait, no, I may have one on the origin of life. It'll be perhaps a 10-hour total debate. It might be
Really?
yeah, it might be split up into 5 segments. But the reason I said 10 hours is when it's a short debate, the other side can just what they use the term
Gish
in
Gallop or?
no, they call it filibuster. They'll just
Okay, yeah.
start arguments and they never get to the topic. And like if they interrupt me, I'm never able to finish the sentence. They just start arguments about other things. In a long debate, they can't do that
Yeah.
because
I
if it
always
stretches
think
out over 10 hours, it's like, okay, we've stopped arguing. Let's start going through all the papers and textbooks. Now we have a real discussion. And it's when it's a 10, 20-hour debate stretched out over, say, a few weeks, then the case for the improbability of, say, abiogenesis or evolution starts to become really apparent. In a short debate, when it's superficial, you don't see it. But like, I'm going to argue against the natural origin of life, and I'm going to go through this. I have like the Stairway to Life has like 12, 14 chapters of all the barriers. There's no way. I mean, if I spent just 2 minutes on each step in the Stairway to Life, that'd already be half an hour. That'd be enough for one short debate. And I'm like, no, we're going to go through this. If we're going to do it justice, we're going to spend an hour on each step or half an hour or even 15 minutes. Because each step would in and of itself be enough to break naturalistic evolution. And so, yeah, that'll be, it hasn't, I don't think the details have been worked out for that, but I'm also intending that it'll help structure courses. So if you want to study the origin of life and arguments against naturalistic origins of life, I'm thinking about doing classes right here on this Evidence Reasons Academy, because it takes a little bit of understanding. It doesn't take an entire biology or chemistry degree to understand it, but it takes a little bit of work to learn just enough chemistry and principles like the law of large numbers to be able to understand the arguments well. So thank you for asking. When that debate happens, I'll post it on my channel. So there were some things you mentioned about, I'm going to just paste the comments in the side chat about.
I also think that if we have debates, it should be very specific. For example, you could have a debate about, does Genesis 6:3 prove Christianity or something like that? If you see what I'm saying. Maybe that's too specific, but I always think it's so global that people just talk over each other, and it's not a real debate. It's just, I mean, the whole idea that you could debate evolution or debate complete worldviews in 1 hour is just ridiculous.
Yes, and that's why I'm not going to. There's certain. I may engage in debate only for advertising, but the real success is in discussions like what we're having, where we examine things carefully, and other people who are interested in actually just learning rather than watching theater and drama, which a lot of debates are. This is where the argument really is won or lost. So as we have our conversations, we'll have a better idea what works and doesn't work. So there'll be some of this means we might have a topic that one day is just like that really wasn't a good topic, and that's okay, because that's how you find out what the good topics are. I've had that in my private apologetics and evidence and reason study that I have with just people from my church, and we've had some days where the topics we studied ended up being kind of not so good. You say, yeah, we're not going to use that. We're not going to visit that topic again anytime soon. So, or ever. So, why don't you share your thoughts about the age in Genesis? You said, what was the passage you were talking about?
It's Genesis 6, verse 3. And okay. I don't know, maybe you can quote it.
Let me look it up. Genesis 6. And well, why don't I just read the first few verses in chapter 6. When man began to multiply on the face of the land and daughters were born to them, the sons of God saw that the daughters of man were attractive, and they took as their wives any they chose. The Lord said, my spirit shall not abide in man forever, for he is flesh. His days shall be 120 years. 120 years.
Yeah.
So you had some interesting thoughts on this, which I really appreciated. Please share them.
Okay, so the issue is that there are basically a couple of interpretations of this verse. Probably the most common one is the one in which people will say that, for example, I guess Luther and most of the church fathers believe that interpretation, in which the 120 years refers to the time from when Noah started to build his ark until the flood happened. However, there are some problems with that interpretation, because actually if you look at the chronology of what's talked about, I think there's only about 100 years between when he started to build the ark and when the flood happened. So it cannot refer to that. But there are other issues as well. But so if we look in antiquity, so these are not modern interpretations. When we look at Josephus and Philo of Alexandria, and so these are people who were living in the 1st century after Christ. So that's pretty early, right? That's almost 2,000 years ago. So these people, both Philo of Alexandria and Josephus, interpreted this verse to mean that the maximum lifespan of humanity would eventually become 120 years. And what's interesting is that, until the 20th century, the oldest people we knew about were somewhere around 100 years. And actually, the oldest documented living person, and I'm not including all the fake, myths from Russia of people claiming to live 200 years or something, because that's clearly fake. The only actually documented individual who lived over 120 years is Jeanne Calment, a French woman. And actually, recently, some gerontologists started to doubt whether that's actually legitimate. So the only instance in human history of a human being living over 120 years is a disputed case. And if you will look at, the list of oldest verified human beings. The second one will be a woman named Knaus, an American woman, and she lived until 119 years. And actually, physicians have calculated that based upon different scientific data points, because of course a lot of people want to, some millionaires, for example, Bloomberg, and I guess what's his name, the Tesla guy, they want to invest in
Elon Musk.
Yeah, in longevity research. So there's actually quite some money going into this, but because these people want to live forever, right? So, but they want to live forever in a naturalistic sense. But scientists are basically saying no, there is a limit to our lifespan, and that's basically up and around 120 years. So basically, this is how the argument goes. We know from science, apart from the Bible, that basically people can only live up to 120 years, no longer. The second point is the Bible has this verse, it's almost like a scientific hypothesis, because it says it has a number, so it has the 120 years. It's not like the fake stuff in the Quran, the so-called scientific stuff in the Quran, with just like, God or Allah doesn't like wine because wine is bad, stuff like that. That's not scientific. This is like a scientific hypothesis. This is like people will live up to 120 years. You can test that hypothesis, and we do test it, and it holds. It's true. So how could people in the Bronze Age, how could they have known that if that's not very likely? So the argument would be, so the atheist might say, well, that's just you're just looking that into the text. You're reading that into the text. But no, I'm not, because Josephus and Philo, who lived 2,000 years ago, they actually interpreted this verse that way. So this interpretation is very old, and it's now being confirmed by science.
And I want to tell the viewers, I was very appreciative of being told this, kind of in an odd sort of way. We have loved ones who are elderly. We want to find, maybe it's just kind of my nature to say, okay, I'm trying to plan for the future. What are the odds of someone that I really love not being here? And so I just did a random Google. I said, okay, how many years what are the odds that someone will be alive 5 years from now? And it gave this calculator. And it said, okay, if you're age 50, these are the odds you'll be alive another 5 years. And that table went all the way up to exactly 119. Because at 119, they said the odds, or like they say 120, the odds of being alive past that are zero. So the table didn't go beyond 120. And I've seen that number pop up so many times. And so I brought that up to some study group, and they said, no, that's the number of years that were needed to build when Noah started building the ark. But what you just provided with the ancient interpretation by Josephus and Philo of Alexandria, that gave me a renewed interest in this discussion, that 120 could actually be the limit. And speaking of biophysics, there's a lot of interest now. We could actually, as you're saying, the medical researchers saying that's the limit. This is how we're able to estimate some of these limits using these principles. So that would be really amazing. So that was great. So we're running, we're almost at an hour, and maybe that'll give us time before we meet again to think about what we might want to do. I will be.
Wait 1 second.
Yeah. Yes. Not a problem.
I'm sorry. Someone just told me they are storming Congress right now. So.
Wow. Wow.
And should we do you mind, because we talked about everything, that I wanted to ask you a couple of things
Yes.
in the how do you say it, the how do you say it, if we can talk privately for
Oh,
a
we
couple
call
of
it
minutes.
backstage. We can
Yeah, yeah.
talk backstage. So what I just want to announce to our listeners that now they're storming Congress. Which country?
Your country.
Okay. Wow. So, oh well. Um, I just have to deal with it later then. I wanted to say that um, I began looking at going through Change Laura Tan's molecular biology course. And I may be actually trying to redo it so it's available on the internet, because I can speak English better than she can, for one. And then also the way she teaches it in the university, there might be a way to do parts of that on the internet that are not quite so lengthy. So I might actually just go through the entire basic course that she teaches almost word for word.
Can you hear me?
Yes.
Okay, because you were cutting out. So
Oh, sorry. I was saying that I may be teaching Change Laura Tan's molecular biology course that she teaches in university. So I'll post that. And if you're interested in joining some of those discussions, that'd be good.
yeah.
So it might be that I'll just teach even just the first few chapters and say, okay, if you hadn't had this course in chemistry, let's just stop and learn what we need just to understand what she's saying. And I'll tell you this, I haven't had organic chemistry, but I was able to learn biochemistry and a little molecular biology without the organic chemistry. And that's that should be encouraging, because then that should mean parts of this should be easier. Are you interested at all in cellular biology?
Well, I know the basics that I was taught in high school, like all the organelles and stuff like that, but never read about it in my spare time or anything.
Okay, well, we'll just play it by ear, what works. Emery Moyna, he ends up working very late in the evening, up until, I mean, he's only free in the evenings. I was actually hoping he'd join us, but he said he can't. So
Yeah.
when you see that we have an afternoon show, that was probably pre-recorded like the night before or 2 nights before. So that's how come we had an afternoon show. It's not that he and I are really free at that. Not that he's really free at that time. I often am. So with that, I'd like to thank all the viewers who are joining us live and through recording for this this discussion where James and I had just a chance to talk to each other. And till we meet again, God bless you and have a great day. And James, I'll meet you backstage.